Think I'm okay to get started?
Yeah, whenever you're ready.
Yeah, I'm ready. All right, everybody. Thank you for being here, and thank you to those online. Today, John Brunsfeld and I are going to be talking a little bit about SQLAlchemy. I'm going to give a high-level overview and then kind of give a demo of just the cool capabilities of SQLAlchemy. And then John will be here to support if there's anything that I missed on, or if there's any questions that I can't answer. I also want to note that pictures of database code isn't the most appealing, so John generated some AI generated alchemist photos for this. So yeah. So to start, what is SQLAlchemy? And so say you're coding in Python and you're putting together a program or an application, and you need to contact an SQL database to get some data, to push some data there. What you're going to have to do is you're going to have to write raw SQL queries that will be executed from Python. So these SQL queries are strings, and oftentimes they can get a little out of hand, and they're very particular oftentimes in the syntax, and the syntax can be different across different SQL databases. So say you write some code base, you end up wanting to migrate your database to a different kind, you're going to have to go through and rewrite a lot of code, and that can be problematic. And so that's kind of where SQLAlchemy comes into play. So SQLAlchemy is a Python toolkit and ORM, which is object relational mapper, that acts as this buffer between your Python code and that raw SQL needed to access that data. And so I said the ORM was kind of one of the cool features. And what that does is it allows you to define Python classes, and those classes are then mapped to some of those tables from your database. And so you still may wonder, okay, so why are we using SQLAlchemy if I can just write the raw queries? And so there's several key points that I just want to touch on. The first being that you can use the same queries across different database dialects. So that allows you flexibility in your program. Also, these queries from SQLAlchemy are easier to maintain as your application expands and grows. And so I'll be showing some examples of why that's the case here in a little bit once we actually get to the coding. Also, the ORM adds this layer of protection against SQL injections. So when you're building your program and you're having to concatenate all of these different strings together, there's the chance that you didn't format something properly and you have this vulnerable SQL query. And one of the cool things about SQLAlchemy is that you write your queries using this Pythonic kind of syntax, and it creates the strings for you that are all properly formatted. They escape everything properly. So you don't have to worry about kind of some of those same things that you'd have to worry about writing raw queries. And another benefit, which is kind of one of the reasons why I like it so much, is that it's very Pythonic. So I'll show you in a little bit. If you write code in Python, it'll just make sense to you, which also is helpful when creating applications. And so instead of providing more kind of boring details, I figured we'd just get right into some code. So before I start kind of any of these projects, when we're connecting to databases or creating an application, we want to set up a virtual environment for Python. And so if you have Python already installed, you can go to the directory where you want to be in your terminal, and you can call this python3 -m vn. And then the vn here at the end is the directory where your virtual environment will be. So then we activate that here with the second line, and then we can get going. We want to start by making sure that pip is up to date with the most recent version. And so pip is the package management tool for Python. Once we get this, then we can install SQLAlchemy. And so it's important to note that there's the most recent version, or the kind of the current release, which is version 1.4.44. And so all of the examples that I'll be showing today are specific to that version. There's also a new version 2 that's like a beta version, and the syntax is slightly different. So if you want to kind of use some of the examples that I'm going to go through today, it's important that you specify the version when you install this package. And then also the final package that I install here is this PyMySQL. And so for my examples, I'm going to be connecting to a MySQL database, and you need to provide a connector to SQLAlchemy so it can actually connect to the database itself. So there's a wide range of different ones for just given the SQL database that you're using. And so there's pretty good support on the SQLAlchemy documentation, kind of telling you what you need to install. So it's pretty straightforward. And so we're going to get directly into a Jupyter notebook. And so in Python, a Jupyter notebook is this nice notebook where you can do markdown for describing your code, and you can also execute chunks of code. And so here at the top, I've just included a link to the documentation for the version that we're working on. So this code can be distributed afterwards and people can have that information. And so we start this whole process by importing some important libraries that we're going to be using. We have things that are specifically from the ORM module of SQLAlchemy. So this includes things like relationship, which is going to help us link our tables, which I'll show down below. There's this session maker, which allows us to have this kind of continuous communication from the database to our Python code. And then in this second line here, we have all of these different kind of types of data that we're going to have. So we have the table, we have a column, we have all these different data types. And this is going to help us describe data in Python that can be mapped to our database. We also have this declarative base, which I'll get to in a second. And then I have this configuration file where I have some kind of hidden details about my connection information to the database. While I hide that information for connecting to the database, I do provide an example of what the string should look like. And it's really straightforward if you already have a database set up for entering your credentials and getting going. And so for this example, we're using this declarative base. And so what this is this is essentially a catalog that keeps track of all of the different tables that we're going to describe here in Python. So this will look slightly different if you're implementing this in, say, like a Flask application. There's a slightly different syntax, but the idea is the same. Is we have this base, it creates this mapper for our class, and also the table object itself. And so this is important for us actually being able to map our data from Python then to our database. So here in this first example, I have two tables. They already exist. And so looking at those existing tables, I input some of the fields here. And so it's critical for these classes that you have a table name, whether you're creating a table, whether you're linking to an existing table, you need to provide the name here. You also then come down and you describe your different columns that are in your database. And so if you remember, this is one of the things that we imported above, as well as this different data type, integer. And so you specify your column, the data type, and then there's a bunch of other things that you can describe about it. So whether you want to be able to have null values there, there's a parameter for that. Whether it's a primary key, a secondary key, things of that nature. And so you see here, we have our two tables, and you'll see that we have this resource ID in our location table here, which is going to link to our resource table. And so in the existing database, there was a foreign key. And so here we can describe that, hey, this is a foreign key to the database table resources. What's important about this is communicating for your SQL. So it's saying in SQL, these tables are related. We come down here and we describe this relationship, which is saying in Python, these objects are related. And so it uses that key from above. So it kind of figures that step out for you. But you need to declare, okay, here's the relationship in SQL, and here's the relationship kind of in our mapper, or in our object, sorry. And that's why you'll see here that we have this resource name that's referring to the class. And then right here, we have the resources.id, which is referring to the actual table name itself. And so declaring these relationships will allow us to do some cool things here in a minute. But that's the basic idea behind kind of developing these classes, which represent tables. And so as I kind of mentioned above, each table has these different attributes. And so I'm misspeaking a little bit in terms of these classes are actually just describing metadata about an underlying table. And so these classes have attributes such as the table, which we can see here on this code line 5. And it also has a mapper, which is mapping this Python to SQL. And so we won't be accessing this table object directly until a little bit later, but it's important to know that these metadata kind of classes objects have this table within them. So now that we kind of have an idea of what these kind of tables look like once we put them in Python, we then need to establish this connection to the database itself. And so this is where this block of code comes from. The documentation does a really good job describing what these different elements are. So I'm not going to dive into it too heavy, but essentially we have our information, which I have hidden in a different file. And what that looks like is this string where you specify the SQL dialect, you specify the driver that you've installed for connecting to that SQL database, username, password, the host, the port, and then the database name. So it's pretty straightforward. You can pull that information from your database, plug it in, and you're good to go. You create this engine and session, so you kind of establish this connection between Python and your database. And once we have this session, we're ready to go. So we can come down here and we can start writing queries to select data from those two tables that we've described. And so what a query essentially looks like is you have the session, you call this query, and you provide that query with the different fields that you want to retrieve. And so if you remember, scroll back up, each of these has these different fields that you can access. So we come down and we see that, okay, well, it's the class name or table name dot field. That's how we're going to kind of access these different attributes. And then if you want to access attributes from multiple tables, you're going to have to join those data, which in SQL, you're going to have to do this join on, where kind of this longer syntax. Whereas here, because we defined relationships, we can just call join and give it the table that we want it to join with. So here's a quick example where we are going to take the latitude and longitude from the location table that we described. And we also want the associated resource title that goes with that latitude, longitude. And so then, because we're asking for things from two different tables, we're going to join them. And so we join that resource, and then we want to limit it to 5 returned results. And so when we run that, oops, it looks like I didn't run a bunch of stuff on my way through. We'll do that real quick. So when you run that and you look at the query itself, you see that this query is an object. And so with this query object, you can access it by iterating through the different rows. So you can iterate through it, or you can call an all after the end, and that returns everything as a list, which can be useful in some scenarios. But what's really cool is that if you don't, and you just call it as is, and you have this object, you can add more things to this query iteratively. So this allows you to say, create conditional statements where you want to add some things at first. You want to see if some condition is true, and then you can add more things to this query.
Tanner?
Yeah.
So in your query there,
Yes.
So you specify, location latitude, location longitude, and then resource title.
Yes.
You're not, and so you're not like if I was to imagine doing the actual SQL for that, you'd do like a select, on the location table and then later join it, right?
Yes.
But here you're explicitly joining it to resource. Is that because you're the first couple of things that you're looking for are from the location table? I mean, why not join location instead of join resource? Just wondering the order of things there.
Yeah, it's the first couple things. I believe it's I don't want to be wrong here, but I believe it looks at the first element.
And that's the main
And that's the main
Okay,
table that it's
right.
looking at. And so then you join things from there. So even with this simple query here, you can see I've printed it out, what this would actually look like in SQL. You can see that looks a little bit more frightening than our nice little single line up here above. And so when you iterate through this query object, once you're ready to see the results, one nice thing is that you can just call it as a dictionary. So just as a simple example, you can see here that we have our location latitude, our longitude, we have a title, and we've limited it to kind of those 5 entries. And the kind of the interesting part about this is if there's something that you want it to do, you're like, oh, well, I can do this in SQL. Oftentimes there's some call that you can make that will do that same thing, and it be pretty straightforward. So we've shown just some basic queries where we're selecting data. And so now I just want to transition into filtering data. And so here again, I could do this all in one line, but I just wanted to show you the ability to kind of tack on to these queries as you go. And so here again, we're taking our location latitude, our longitude, and our title. We're joining that. But then we want to look for, say, a longitude between 2 points. And so here we do this dot filter, and we add the condition that we want to filter by. And so it's really straightforward in Python to do, or in SQLAlchemy and Python to do some of these filtering, where it would take a little bit more if you were trying to write the queries like this between. Simple, one little chunk, whereas in SQL, it would be kind of between this, and it's just a little bit more work.
One more question, Tanner. So,
Yep.
I assume that if you tried to do that join there, but you forgot to establish your relationships,
Yes.
then you get some sort of easy to interpret error message.
Yeah, it will tell you that it doesn't understand the relationship between them, essentially. And so if you don't describe your relationships in kind of your class itself, you can still join things, but you just have to explicitly say, we want to join this class. Are the elements that they should be joined by. So it's this equals kind of your foreign key to it. And so you can still do that. You still have all of the nice kind of appendable, like you can append things iteratively, but it's just a lot cleaner if you define your relationships above.
Okay. And it'll tell you if you're missing a foreign key or whatever.
Yeah. And so, okay, so now we have filters for our queries. One of my favorite things that I've learned so far is this ability to iteratively build these queries using lists. And so say you have this list that could potentially grow. Hey, we're not sure, we might have more fields in the future. Hey, here's this field list where if something that is added in the future, you can just add it to your list And you don't have to change your query at all, actually, because if you see here, we have a field list, which is going to be those fields that we select, and we have our filter list. And so you can imagine iteratively adding things to these lists, given certain conditions, things like that. And all you have to do is add this star before that list. So we have field list here, and it unpacks it for you. And so it allows you to kind of have this consistent query where all you need to do is update your list with the different things in them. And so here's the filter list. I should also note that this is also, you can do this with joins as well. It's a little bit different in terms that you have to loop through and each iteration through your join list, then you add it to the query, but still simple and still allows you that ability to kind of grow down the road without breaking your entire kind of database integration type stuff. I should also say that maybe sometimes you have these different database fields that might be named the same thing, say from different tables, and you might want to rename something so they're distinct, or you might also want to rename something based on a program you currently have. Say it references a dictionary that has a certain key. You can change one of the key names here for your variables with this simple just label. And so if we run this, we can see that latitude and longitude have been renamed according to our labels up above. You can also see that given this kind of relatively simple setup, this is what we would have to write if we were doing the SQL, which is not entirely fun. Okay, so we've shown how to kind of pull data from these existing tables. We can kind of figure out how to structure them based on this already existing setup in whatever database we're using. But what if we want to create something from scratch? Well, all we have to do is have a database set up that we can connect to. So here again, we have this connecting information, which pretty much stays the same. I just renamed it because I don't want to interfere with kind of the other stuff that I'd already defined. So we run that, we have this new session going, and this is in a different database, by the way. I'm not corrupting anything, don't worry, Luke. And so we have this new database with nothing in it. And so we wanted to create a user table. So we have this test user, we give it a name, we have our ID, which is the primary key, we have a password, and we have an email. So this is just a simple setup for a test example. And so we're going to go ahead and run that. And this is where that table object comes into play. So when you're creating tables, you can't create a table in SQL from the metadata that we described. So that's the class. We have to use the table object. And so all we do is we take our metadata class object and we access the table object from that. And so that's what this looks like here. So we have this table and we have some information here. And so because I ran this earlier to test it, we're going to actually drop the table first, which you can see we take the test user, we take that table object, and we use our engine to drop that. So we're going to run that. Looks good. And then we are going to recreate that. So that is just this create option here.
And there's no like commit operation, right? Like when you issue the command, it actually fully executes it.
So there's certain things that don't require commit and there's others that do.
Okay.
And so this engine, when you call creating a table like this, you don't have to. But in this next example, we will have to commit it.
Okay.
So we have our test user table. It's completely empty, and we want to add a new user in there. So all we have to do is call that class where we have our test user. We provide this password and we provide this email. We take our session and we add that new user that we've described here, and then we commit that. To commit that, addition to our SQL database. And so we want to make sure that this actually worked. And so we can use our session again to query the test user to see the email and password in there. And this time, because I'm just checking if data exists, I don't need to iterate through and create this nice dictionary. I can just dump out a list and check that something happened. And there we are. We have the password that we had up here, and we also have our test user email. So then just to show it again, we have this different user, which we're going to call user 2. We want to add him or her, and we take a look here. And there it is, we have 2. And go ahead. Yeah.
So obviously, different database platforms have different data types.
Yes.
Right. So like MySQL has varchar, other things,
Yep.
other data types. And so this handles all that mapping, right? So like you have a string type and you can specify its length, and that I assume on the back end probably converts to a varchar.
So what you have to do in some circumstances there are these special data types like varchar. And so what you do is, I don't remember the module exactly, but there's an SQLAlchemy dot something dialects, and then you import those data types. And so you say, okay, this is going to be a string, whatever in Python, but in SQL, it needs to be that varchar, whatever. So there's ways to describe those kind of specific data types. Like I think there's one for JSON in MySQL. There's all sorts of them. So, and that's one thing to consider too, is if you're changing to a different type of database, that is something that you would have to change if you have any specific data types.
Do you know if that extends to like some of the more sort of advanced enhancements to MySQL, for example, like the geospatial stuff?
I haven't actually experienced that yet, so I'm not sure. I've mostly just worked with kind of basic data types, JSON, and yeah, that's a great question. I'll look into that.
And then one last question: what if you need to alter it?
So in the documentation, it says that SQLAlchemy doesn't directly support kind of those changes, but they have a module that does for migrations. And it's like an old kind of, what do they call it? I don't think they support it anymore, so they use like a new kind of third party, I guess, for doing those migrations.
The makers of SQLAlchemy make a package called Alembic. And Alembic is used to migrate and alter your database. So it's another package by the same creators.
Okay.
And John, you were showing an example the other day, and the migrations is pretty simple, right? If you're going to change
To migrate,
Yeah.
you can just make changes to your model. It will scan the model, detect what you changed, create migrations for you, and then you just run the migration.
And the migrations will migrate to a new table.
It will alter the table in the ways you altered your underlying.
It will alter it in place.
Yep.
Okay.
Yep. With some caveats, but
Yeah.
Yeah. So there's obviously tons of rabbit holes you can go down with this SQLAlchemy. I just wanted to show kind of some examples that might show how this could be useful for others' projects and might get people interested. Definitely what kind of got me down the rabbit hole was the cool kind of unpacking lists, which allows you to iteratively create these kind of safe queries that are generalizable, but will also kind of extend and grow over time, which I thought was pretty cool. And so we're back to slides, and I have one left. Any questions?
So I've seen code where people will use SQLAlchemy to convert a table or a query to pandas data frame.
Mhm.
And then like interact with the database through that mechanism. I'm wondering if you've experienced that or have.
So I haven't experienced that yet, but I also kind of seen those similar, just like, I mean, the same capability that you're talking about. So it'd definitely be something cool to explore in the future for sure. I know that you can directly interact with, you can call like SQL queries from pandas, can't you?
I've done a little bit with SQLite,
Okay.
but not with any other kind of query.
Mm.
I think it probably doesn't do nearly as much as SQLAlchemy.
Anything else? Cool.
Okay.
Well, I'll go ahead and stop share.